So at the end of today's lesson, you should be able to describe how these parent functions are in comparison to the transform functions. So we know that in exponentials, the A represents the initial value or y-intercept always, right? And that B represents the common ratio or rate. And that's always what happens, okay? Now look at this function. This would be considered a parent function because nothing is happening to it. We have the rate. Do we have an initial value? If there's no initial value in front of it, then it's a 1. Everybody got that? There's no initial value, it's a 1. So we've already learned A and we've learned what B means. Now we have to learn what it means to change the exponent up here and to change the bigger number out here, because that means that something is going to happen to your graph. It's going to transform in some way. And you're always comparing these to what kind of function? Parent function. These are like the baby functions, and this is the parent function. The parent function can also look like this. Watch. Okay, it can look like this. It doesn't have to be the number 2. It could be different numbers. The parent function is just a common rate or ratio with an exponent. Just a regular exponent. Nothing being added or subtracted, nothing being multiplied, and then nothing at the end being added or subtracted. All right, so I want you to look at the next slide for a second. I ask you guys to click on the Desmos slider. I got it. Again, it goes back. So we're looking at the Desmos slider as soon as I can get the shared screen to work. Okay, so we already know what A represents. What does A represent? The initial value. So let's write that down. Hold on. It's gonna take a second. So A always represents the initial value, or what else is it called? Y-intercept. So over here, we're going to put y-intercept. So y-intercept, or what else? Starting value, or AKA initial value. Good job. What's the B represent? Yes, common ratio / rate. So B represents the common ratio / rate. And then exponential functions are always raised to the what power? X, right? So today, now we're going to learn something new. It's x. We're going to extend this equation a little bit more. So I want you to write this down. This is now what your exponent is, plus k. So we already knew what a, b, and x were. Now we need to figure out what h and k are. So on Desmos, says place a equals 1 and b equals 2, and then move h around. If you do that, what happens? See if I can go here. Okay, so a is 1, b is 2, right? Which one am I messing with? Okay, so I'm taking h, and it says to take h, and what does it say? Just to move it around. So watch what happens when I move h. Is h in parentheses in your equation? Is h in parentheses? Yeah, so that means it's going to be the opposite of what we think is actually going to happen. So watch when I take h and I increase the numbers. Watch. I'm increasing 1.9 through 4.9, 5.5, 6.3. What's happening? It's moving which way? Left. Would you have thought it would have moved left? Not really, because it's, if we increase numbers on a number line, we're really thinking to go the opposite way, right? Right. So it's moving horizontally in the opposite direction as what we would think. So what if I go to the negative numbers? Where would it be? All the way to the right. Look at the negative numbers right here. See them? So what do you think h represents? But what's happening? Is it shifting left or right, up or down? What's happening? Horizontal. So h means horizontal shift in the opposing direction. So if logically your brain is saying, oh, it's +5, so I'm going to move right, you're really going to be moving which way? Left. Good. So parentheses opposite, right? So think about this right here. Put opposite. All right, got that so far? Okay, so I'm going to leave A, B, and H alone. And my next question was to move around which one? K. Watch when I move K. I'm going to take K and I'm going to move it in what I would think the positive direction. What happened? Is it going in the right direction? Because my numbers are moving up. Is my line moving up? Yes. So what kind of shift is this? Is this vertical up and down, or is this for horizontal right and left? Vertical. So what would happen if I made it negative? It will go down like that, right? So these special little numbers that go in here for H and K are manipulating your graph certain ways. So K would be what shift? Vertical. in the opposing direction or in the true direction? So you got that? Okay, look, based on this, you guys come up with some numbers and tell me based off this equation, I want you to do, okay, f of x, what do you guys want the a to be? You can pick any number you want. 2? What do you want the b to be? 5? What do you want the horizontal shift to be? 7? So plus 7. What do you want the k to be? Another 5? Okay, so write down our second period equation. Before I even start taking my slider that I made and going back and forth with it, tell me in words down here, like tell me what you think is, like write this equation down. Tell me what you think is going to happen. What's the parent function? Which one of these is the parent? Your big daddy function. 5x is your parent function. Write that down. That's your simple function, right? 5x, because that's just your rate. You'll see. Then we have the 2, 5x, which is your baby. So what happens? Like we know where to start. Where's the graph going to start? Where's the graph going to start? 2. What does that x plus 7 mean? How it moves which way? So you guys are telling me this is supposed to move what way? Horizontal shift to left or right? Left. What's the 5 mean? So vertical shift which way? 5 is. This is talking about the horizontal shift, and this is talking about the vertical shift. Vertical shift up and down, but this is going to be up. Okay. So watch what I do. Take your Desmos slider. What is A? 2? And if you can't get it to work, watch this. 2. B is 5. H is what? 7. K is what? 5. Oh, it's all up in there right here, right? Then if I wanted to, I could take the parent function which is 5 and watch this. Okay, so I want you to look at this line. I'm gonna zoom out some. What's my thick orange line? The parent or the baby? This is the parent function. This is the baby function, right? So in comparison of the parent to the baby, does the baby shift to the left 7? You need to look closer. Does the baby shift to the left 7? Yes. Does it shift up 5? It goes from 1. Does it shift up 5? Yeah. So do you see how these exponents and this number at the end manipulate this in order to move it and arrange it in different ways? So you're always comparing the parent function to what the baby functions have. So you got this? Okay, now look at this one. These are what parent functions actually are. So I want you guys to look at all of these because we've only studied 3 of them. And the ones that you should already know. Yes, but you don't have to worry about that yet. So we've learned linear parent function looks like that. Quadratic parent function looks like this. Exponential parent function looks like this. Okay, that's a B. Well, B. So those are the 3 that we've studied so far, and that's what we compare those to. All right, some things that you want to know that you have not found out from me yet. Okay, we have talked about vertical translation, right? Is that H or K? Vertical translation is what? K. So this is vertical. If you have not wrote it down, write it down. Vertical shift. If it's up, it's plus. If it's negative or subtraction, it's what? Down. Good. So that's vertical translation. Horizontal translation. Do you see the example here? What's important about these? This one says 2x to the minus 2 power, but does this mean minus 2? It means positive 2, so put this is the opposite. So if it's 2 units to the right, it's going to be what? X minus 2. 1 unit to the left, it's going to be X plus 1. So those are horizontal. So this one right here, see how it's 2x to the power and then minus 2? So minus 2 in your head you would think left, right? But it's actually right. You see how it says right? So look at this one. This says X plus 1. Yes. So you got it? All right, these are the 3 that we have not talked about that you need to write down. Okay, and they can go on the back of that sheet or they could go on notebook paper. So the number in front I told you guys that that was the initial value, but it's also going to be a stretch or a compression. So A, if A is less than 1, it's compressed. Just write that down. If A is greater than 1, it's stretched. So I'm only talking about A here, right? What about if A is negative? What happened with our parabolas when A was negative? Do you remember? Which means it reflected over the what axis? X. So if A is negative, you got that so far? So if A is negative, just like with a parabola, so the parabola is like this if A is positive. If the parabola is like this, A is negative. Same thing happens with an exponential. So these are a little bit weird. The horizontal stretch or horizontal compressions are weird. I'm just going to tell you that up front. They're really weird. Look at this example right here. Look at your exponent. Are you adding or subtracting anything? What are you doing? You're multiplying by something, right? So it's stretched by 5, which again is the opposite. Do you remember when we were talking about this being opposite? This is also opposite. Because look, what's the opposite of 5? 1/5. So you're basically doing the reciprocal of it. Not necessarily the opposite, but the reciprocal. So put reciprocal. Okay, 2 and then 3 to the x power. 3 times x power. So the reciprocal of 3 is what? 1/3. So if it's 1/3, it's compressed. So basically this whole chart is telling you, be careful with these. Look. Also another weird one, watch this. We said that if A was negative, we said that A, look, if A is negative, it will reflect over the X. But if X is negative, what's the like what else can you reflect over? Y. If X is negative, reflect over Y. This is the hardest part of exponentials, is trying to figure out what goes with what. Like they'll give you an equation and then you have to figure out how is it translated. But guess what you can do if you get stuck and you don't know? Put it in your calculator, right? And watch and then look at which way it goes. So are you good with this part? All right, flip your papers over. You see that sheet I gave you? If you had to guess, what do you guess the parent function would be? Okay, our parent function is going to be what? Yeah, this is our parent function, right? So for each of these, what I'm going to have you guys do is I'm going to have you guys write common ratio. So write that down, common ratio. So you put CR. Then I want you to put the initial value. Then I want you to put the horizontal and the vertical shift. So like for this one, this is the parent function, right? Because look at everything else. Do you guys see the changes? What does not change about this every single time? Y equals 2 to the x power, right? That does not change. So your ratio for this one is 2. The initial value is 1. Does it have a horizontal or vertical? No, so you put NA. All right, I'm going to give you guys like 5 minutes to try to get as many of these done. If you want me to check, just raise your hand and I'll come check. Oh my God, who is up? Keep going. Yeah. The horizontal stuff is attached to the X. There's no initial values. A horizontal is only just from the beach. The other ones are just kind of green. So that's my cap. Oh. Bring it up. Follow the notes for it. Okay. What am I going to put it under the exponent is opposite? So here's a commercial. That's it. Plus three. Down. Plus three what? Down. You only change the prices. That's down. Yeah. I only have horizontal stuff when it enters the B. Have horizontal stuff. That makes sense. So like this one moves this way. Like it's x minus 3. If you put plus 3, I don't know if you're talking about up or right. Up or down? It's reasonably go up or down. Go which way? The rate, this is the thing. Initial value is sorry. That's what I'm about to say. Everything, that's why for a vertical cut up, right? This down. Find the beam on right or left. Matthew, are you scared for me to check you? You're on the e-pads, you need to go to, Jimmy, what slide are you on? 4. You need to go to slide 4. And look, the initial value doesn't change in this little right here. You need to figure out which parts are which. Vertical, but put up instead of just putting up. Put, what I mean? So your big numbers are there. Right, so if you can follow down to I was just left or right. For which one? Okay, remember that those are for anything that's in the exponent like value is gonna have to do with moving horizontally. So if it looks like multiplication, it's either gonna be stretched or compressed. And remember, because it's in the exponent part, it's gonna be the opposite of what you think. Remember, the rate, the common rate doesn't change, those two. And then the initial value does change 1/3. I think. No, because that part's right. Wait, pick that up. What doesn't change the whole entire part? The common rate. What sometimes changes? You see how the initial value changes? What does HS mean? Horizontal. That's the big giant number. So what's the horizontal? I'm sorry, not the horizontal. What's the vertical shift here? Up 3. Vertical shift? Down 3. Is this a vertical shift? It's horizontal. Which way? Right 3. What about this one? Left 3, because it's in parentheses and it's part of the exponent. What about here? What changes? The initial value, right? This one, you guys were tricked on. 2, and then 2 didn't change. The initial value didn't change. What changed? Was there a big number over here, like up here? Do you see any more big numbers at the end? Down here, do you see any big numbers at the end? No, so there's no more vertical up or down changes, right? The rest of these are all inside the exponent, so they are all horizontal changes. Got that? Okay, what kind of horizontal change is this one? It says 3x. Stretched by 3. So put HS stretched by 3. Remember, it's the opposite of what we think. Because usually if it's compressed, it's a fraction.
So the number's not opposite?
To what?
The number's not opposite?
No, you would just think of it like by the reciprocal. I see what you're asking. Yes. I see what you're asking. You're saying if it was written out like this, it should be named compressed because that's the opposite. Yes. So put compressed there instead. Sorry about that. And so this one would be what? This would be stretched by 3. So we need to fix that. And I'll fix that real quick. I don't want to mess you guys up, so let me fix it before you get to it. This would be compressed. So put, instead of putting stretch for this one, put compressed, just swap the names. For this one, put stretched. The next one, if the negative is in the outside, what does that mean? It's reflected over X. Good. So it's reflected over X. And then this means that it's reflected up here. This means it's reflected over what? Over Y. Good. And this is reflected over X. So the exponent is always in charge of what? Anytime you have an exponential function like this part right here is always in charge of what? Horizontal or vertical stuff? So this is horizontal. And then the ending, the bigger number, or K, is always in charge of what? Vertical. So that's what you have to have memorized. So make sure that you keep those papers with you because they're super important. Everybody got that?